Assalamualaikum everyone. Today we are gonna solve Unit 4 Physics May 19 paper. Let's start with section A. Number 1. A nucleus of X emits a beta negative particle. Which row of the table shows proton number and nucleon number of the nucleus after beta negative particle have been emitted? Let's go with basics first. This is mass and this is proton. Let's take it as P, and this is our nucleus. When a beta negative particle emits, the mass number stays the same, but the proton number increased by 1. And for beta positive, the mass number still stays the same, and the proton number decreased by 1. For this case, it's beta negative, so we're gonna see which has the same nucleon number. These two. We have to add by 1 because it's negative, so our option is number C. Let's go to next one. A DVD is rotating at 570 rotation per minute. What is its angular velocity in radian per second? We're gonna use the formula W equal to 2 pi n by t. 2 pi n is rotation, 570 by 60 because we need to convert it into seconds. We get 59.8, which is round to 60. Number 3. The diagram shows a simple electric motor. The current in the coil is 0.48. The magnetic flux density is 0.70. The length of XY is 5 cm. Which of the following gives a force on the side XY in newtons? So we need to find force in this side. Okay. Here we can use the formula F equal to BIL sine theta. Here theta will be 0 because the conductor is perpendicular to the magnetic flux line. This is the magnetic flux line, and it is perpendicular to it, so it's like 90 degree. Sine 90 is 0, so we're gonna use F equal to BIL. Our B is 0.07, 0.4 into 5 into 10 to the power minus 2. Where do we have it? In these two options. Now we have to find whether it goes upward or downward. Now we are gonna use the left hand rule to find the direction of the force. First of all, this is north to south. Our first finger will be like this towards the right side, and this is positive. Sorry, this is positive and this is negative. So the current flows in this way. So this will be downward towards you, positive to negative, north to south. So obviously you can see your thumb right now is going upwards. The force is upward, which is our option A. Number 4. A can decay in several different ways. Which of the following decay is not possible? First of all, we need to know that charge, baryon, and lepton have to be conserved for them to be possible. So as this is not possible, so it means one of them is not conserved. Let's start with our option A, first one, charge, baryon, and lepton. Here on the left hand side the charge is 0, and on the right side it's +1, -1, +0. So it is conserved. We don't have baryon here, so it's gonna be 0. And for lepton, it's 0 on the left hand side. On the right hand side it's 0, +1, -1, so it is conserved. Let's see number B, charge, baryon, lepton. Charge is 0, then +1, +0, +1. It is not conserved. This could be our option. Baryon is 0, lepton is 0 because none of them are leptons. So these two are conserved, but our charge is not conserved. So this could be our option. Let's see with number C. charge, lepton. We're not gonna go through baryons because none of them has baryons. For charge is +1 on the left hand side, right hand side is 0, as it is positron, so it's going to be +1 plus 0, so it is conserved. Lepton 0 to 0 minus 1, and that's +1, so it is conserved. Let's see option D, charge and lepton. Charge is +1 with +1 0, so it is conserved. Our lepton is going to be 0 here, and as this is anti-muon, so it's going to be -1, plus this is neutrino muons, it is it is +1, it is conserved, so only option is number B. Number 5, when 2 point charges each with charge Q are separated by a distance R, the force between them is F. 2 point charges each with charge 2Q are separated by distance to R. What is the force between them? Okay, so we need to find the force here. F equal to K Q1 Q2 divided by R squared. That's our normal formula for the first sentence. The second one, they said there is 2 Q's, 2 of both, and there is 2R, which is 4 K Q1 Q2 by 4R squared. The 4 get cut. We basically have the same one as the original one, so it's obviously going to be number C. Number 6, the diagram shows drift tubes at the start of the linear accelerator. At the end of the linear accelerator, the drift tubes are the same length. Which of the following is the reason for this? The frequency of the accelerating potential difference is increasing. Particles are no longer gaining energy. The rest mass of the particle is increasing. The speed of the particle is no longer increasing. If the lengths are same, that means the speed is not increasing anymore. So it's the obvious thing, so it's our option D. The speed of the particle is no longer increasing, because you can see the diagram, the length are increasing. If the length are increasing, the speed will increase obviously. So here as the length are same, the speed are not gonna be increasing anymore. An object moving north with momentum 23 collides with an object moving east with momentum 35. After collision, the objects move off together. Which of the following will give the magnitude of the final momentum in S? Let's find out. This is going there. That is going there. So we need to find this. This is 35. This is 23. So what is this? We're gonna use Pythagoras formula here. Let's take it as x. X equals to 35 square plus 23 square. Option D. Yay. Number 8. Which of the following gives the direction of the final momentum? Let's draw it here a little bit. 35, 23. Okay. We can make it that. This is our resultant. As you can see, the norths are literally here, so we need this angle. So this angle and this are same. This is x, this is x, so we're gonna find this one. This is what, 23, this is 35. So to find this one, this is above, this is hypo, this is adjacent. Then theta equal to 35 by 23. Theta equal to 10 inverse 1, 35 by 23. What matches with this? Option B. That's our answer. Let's go to number 9 now. When a beam of high energy electron is directed at a sample of crystalline material, electrons diffraction can occur. Okay, this can be observed as a set of concentric circles on a fluorescent screen as shown in the photograph. Which of the following changes would it decrease the diameter of the circle? Decrease diameter. First we're gonna form an equation here so we can get the answer easily. Del x equal to lambda capital D by small d. Here capital D is the distance between the sample and the screen. Small d is the diffraction gradient spacing. Lambda is wavelength, and del x is the diameter of the circle, the size of it. Okay, so if del s increases, d also increase. If del s increase, lambda increase. Del s increase, this decrease because it is inversely proportional. Okay, let's see our options here. Use a crystal with smaller spacing between the layers of the atom. Smaller spacing. Here the small letter d is decreasing, so if that decrease, the diameter will increase, so this is not our option. Use a screen further from the crystal. Our crystal, if we increase the distance, that would increase the diameter as well, so that's not our option. Use electron with greater momentum. How can we link this? Lambda equal to h by momentum, which is mv. So if we use this more, if the velocity is more, lambda is less. So if lambda is less, we will get decrease in diameter, so this could be our option. Use electron with lower speed. Here if the speed decreases, this will increase, so this is not our option. Increase in that means it will also increase in diameter. That's not our option. Option is number C. Okay, now next one, number 10. A ball has mass of 0.4 kg and kinetic energy 9. Which of the following gives the momentum of the ball in kg meter per second? We are just going to use a simple formula here. Ek equal to p squared by 2m. We need to find p. Ek into 2m. Ek is 9 into 2 into 0.4. Oh, we do not know the answer, which is our option C. We are done with section A. Next video we will start with section B.